So let us start. So in the constrained motion, right? So we have discussed the particle moving in a circular path with an initial velocity of u, which was given tangentially at the bottom, right? So in that, right, so we will extend our discussion. Constrained motion. So in the constrained motion, this is the circle. And then this is the center of the circle where the particle is tied at this location, and it was given initial velocity of u. And for that, right, so we tried calculating when the particle is moving at any location, the instantaneous velocity, the velocity of the particle v square is equal to u square minus 2ag plus 2ag cos theta. So this was the velocity, and the tension of the string, tension on the string T is given as m by a times of u square minus 2ag plus 3ag cos theta. So this is the tension of the string, right? So with this understanding, now actually we will try to analyze where the velocity becomes zero, where the tension becomes zero, what happens if the particle actually goes exactly 90 degrees and then it comes back, and what happens if the particle goes above 90 degrees and below 180 degrees, and then actually once it crosses 180 degrees, what happens? So all these aspects actually we have to be discussing in detail. Now this is the initial velocity which was given as u, and this is the angle theta at any instant. So this is the angle theta. Now let us consider the place where the velocity becomes zero. So the place where the velocity becomes zero, so this is v square is equal to u square minus 2ag plus 2ag cos theta equal to 0, or 2ag cos theta is equal to 2ag minus u square divided by 2ag. So this is the place actually, this is the place where the cos theta value is equal to 2ag minus u square by 2ag. This is the place, is the angle at which the velocity becomes zero. So at this angle of theta, the velocity is becoming zero. I call this angle as theta 1. So where theta 1 is the place actually at which the velocity is becoming zero. Now if I wanted to find out the height rather than the angle theta, if I find out the height of the particle actually where the velocity is becoming zero, that is more meaningful. Let us say, so this is having a velocity of 0 at this location. Then this is the height of the particle from this location, and the entire length of the particle is, let us say, r is the radius of the circle. Then if this is the radius of the circle, then at this height of h1, the particle is having 0 velocity. So after moving to this location, let us say the velocity is becoming 0. Then this height can be calculated by, so r minus r cos theta. So the height at which the velocity becomes 0 let it be h1 is equal to r minus r cos theta 1. So this is the place actually where the velocity is becoming 0. Now if I replace r minus r times of, here actually a is the radius. So maybe actually I will replace with a itself so that no confusion. So a minus a cos theta 1 is 2ag minus u square divided by 2ag. So this a will cancel out, and then h1 can be calculated as h1 is equal to 2ag minus 2ag plus u square divided by 2g. This 2ag will cancel out, and then the place where the velocity becomes 0 is at a height of u square by 2g. Got it? So at this height of u square by 2g, the velocity is becoming 0. Got it? So any questions on this? Any questions on this? Okay, you can note down this. Now actually we will try to identify the height at which the tension becomes 0. So to calculate the place where the tension becomes 0. So at this place, T equal to m by a times of u square minus 2ag plus 3ag cos theta, and this is the tension. Let us say this is becoming 0 at a height of h1, which is h2 at an angle of theta 2. Let this happens at an angle of theta 2 and at a height of h2. Then actually, so this we can simplify, u square minus 2ag plus 3ag cos theta 2 equal to 0. It implies cos theta 2 is equal to 2ag minus u square divided by 3ag. So this is the cos theta where the tension is becoming 0. And the height of the particle at which this tension becomes 0 is equal to a minus a cos theta 2. So this is the place actually where the tension is becoming 0. Now this is going to be a minus, so a times of cos theta is 2ag minus u square divided by 3ag. So this a will cancel out, and then 3ag minus 2ag plus u square divided by 3g. So this is ag plus u square by 3g. So this is the height actually at which the particle is having 0 tension. Got it? This string is having 0 tension at a height of ag plus u square divided by 3g. Got it? Any questions on this? Okay, you can note down this. So we have got two different cases. H1 is equal to u square by 2g and H2 is equal to ag plus u square divided by 3g. So this is where the tension becomes 0, and this is where the velocity becomes 0. Now, let us say if the velocity becomes 0 before the tension becomes 0. That means H1 is lesser than H2. So, first velocity became 0 before the tension becomes 0. Now, actually, we will try to identify what is the angle for this particular case. Now, in such cases, u square by 2g is less than ag plus u square by 3g. Now, if this is the case, g will cancel out, and then, so it implies u square is less than 2ag plus 2u square, or u square plus 2ag is greater than 0, right? So if this is the case, and we have got the values of cos theta 1 is equal to u square minus 2ag. What is the value of cos theta? 2ag minus u square by 2ag. So this is 2ag minus u square divided by 2ag. Sorry, there is a mistake here. Yeah. So this is 3u square, and this is going to be u square less than 2ag. So if this is the case, the u square value is lesser than 2ag. Now, if you substitute in this equation, here u square value, which is coming out to be lesser than 2ag, hence this value is going to be positive for u square less than 2ag. So if this is the case, obviously this value is coming out to be less than, so if this value is coming out to be a positive value, hence cos theta 1 or theta 1 is always in between 0 to pi by 2. This is the condition because of this reason, which happened because of this reason. Got it? That means when the particle started moving from here, then actually if the velocity becomes 0 somewhere, this can happen only if the angle is lesser than 90 degrees. That means this happens with positive value of tension, the velocity can become 0 within the range of this location to this location. That means the angle at max it can have 90 degrees. Got it? So that is the condition. That means in that case, the particle goes this way, the tension being positive, which essentially means that it will try to drag away from the center. Hence actually the tension will be stiff and the string will be stiff, and it will try to move in this circular path because of the constraint of this particular tension. Got it? So that is one case. Now what happens if both are becoming 0 simultaneously? Suppose if this becomes 0, that is, let H1 equal to H2, where the tension and the velocity both becomes 0 simultaneously. Then the position where it can happen is, that is, H1 is equal to H2. Now in such case actually we will try to find out the angle. Now if this is the case, less than symbol, it is going to be equal, that is u square is equal to 2ag will be the condition where the tension and the velocity both becomes 0 simultaneously. Now if you substitute this condition in this particular case of cos theta, then cos theta value will be 0. It implies theta 1 only possibility is pi by 2. That means exactly at the angle of 90 degrees, both tension and velocity can become 0, right? So this is a place actually that can happen only if the velocity and tension becomes 0. So this is the place, that is t equal to 0 and v equal to 0. Here v greater than, so v equal to 0 and t greater than 0. So this is the place actually if theta is less than pi by 2. Got it? Now actually what happens in this particular case? Now let us find out that as well. First you note down this. Done? Okay. So now actually, suppose if tension becomes 0 before the velocity becomes 0. If tension becomes 0 before the velocity becomes 0. That means, so the tension is becoming 0, H2 is less than H1. So this is the condition. So H2 is less than H1 and H2 value is Ag plus U square by 3G. This is less than U square by 2G. Then this G will cancel out and then it implies 2 times of Ag plus 2U square is less than 3U square, or 2Ag is less than U square. Now here if you notice 2Ag is less than U square. Now here actually at this particular case where 2Ag is less than, so cos theta 1 is 2Ag minus U square. Now if you notice here actually 2Ag is less than U square. So this value is going to be a negative value. So if this value is negative, then actually at this location, so theta can be, so the range of theta so this is in between pi by 2 to pi. So this is the range of the angle theta where it can have a negative value. So cos can be negative. Cos is negative only in the range of pi by 2 to pi. So hence the tension can become 0 before the velocity only within the range of this location pi by 2 to pi. Now at this location what happens is, suppose if the particle is trying to move like this and suddenly if the tension is becoming 0, that means it will become slack at this location. Let us say at this location tension is less than 0, or actually so tension is equal to 0 at this particular location. Now if the tension is 0, then actually it won't try to drag away from the center. Rather than that, right, so it will be as if like it is a free falling body. Now in that case the velocity is already there in the direction of the tangential, then actually it can go in a path like this and then fall down to this location, as if like it is a projectile, because so the tangential velocity is still be there where this velocity is given by the fundamental equation U square minus 2Ag plus 2Ag cos theta. So this is the place actually where the velocity is still be there and the tension became 0. Hence actually the string will be no more be stringent, and then actually it will try to fall down as if like it is a free falling body with a velocity in this direction, which is a projectile for us now. So keeping in the mind that, so let us say this is the y-axis and this is the positive x-axis. Positive x-axis I have taken in the leftwise direction. Now this is the angle of projection alpha. So with this angle of projection, it will try to go in this manner and then fall down as if like it is a projectile. So this is the projectile path. And this happens only in the range of pi by 2 to pi. Got it? Understood or not? Is there any question on this? Here actually, so this place actually before 90 degrees, So the velocity can become 0 before the tension becomes 0. That means tension be there and velocity is becoming 0. Hence actually it will come back with the same tension. Now at this location, tension can become 0 because actually it is as if like falling in a free fall body. So but the still velocity is there. So T can be 0 at this location, being velocity can be positive value. So with that location actually, so if it leaves the body, then actually it will fall down. And the third case is where the particle can complete a circle. So that is the third case. So the condition for the third case will be at this location also tension should not become 0. Then only it can go in a circular fashion. Otherwise it will fall down as if like it is a free fall body. So tension has to be always positive. Then only it will try to complete a complete circle. Right? You note down this. So we are going to analyze the next case as well. Now the third case is at the angle for the particle to have a complete circle. To trace at the angle theta equal to phi, tension should not become 0. So this is the condition for the complete revolution. Now the tension is m by a times of u square minus 2az plus 3az cos theta. So this is the tension. So at the angle of theta is equal to pi, this is at theta equal to pi, this value should be greater than 0. So this is the condition. Now if you substitute the value m by a u square minus 2az and plus 3az cos pi. So cos pi being minus 1 and this should be greater than 0, and then u square minus 5az should be greater than 0 so that it can complete the circle. So for this actually u square should be greater than 5az, and this is the condition for the complete revolution. So this is the condition for the complete revolution. Now at this location, what happens is we have got actually, so the velocity equal to u square minus 2az plus 2az cos theta. So this is the velocity. Now if I substitute theta is equal to pi in this particular case, u square minus 2az plus 2az cos pi. So this is going to be u square minus 4az. Now if you notice, u square value is definitely greater than 5az for the condition where the tension is not becoming 0 at theta equal to pi. Now if you substitute that value here, the minimum value of u square is going to be 5az. Now if I replace it here, then it is going to be 5az minus 4az. So this is az which is greater than 0. That means even the tension is becoming 0 at this location, the velocity is still be there. That means tension is not having a value which is 0. That means the t value, when the particle is trying to move at this location, we proved that the condition is should be greater than 5az. U square value is greater than 5az. If this condition is satisfied, tension is not becoming 0 at this location. And then there if you try to calculate the velocity, though if u square is equal to 5az, the tension can momentarily become 0, but still the velocity being there, it will go in a tangential fashion like this. That means, so there will be a slag a little bit of time at this location, but the stone will not fall down as if like it is a projectile. because momentarily it will become 0 and then the velocity is there, hence actually it will try to drag again back so that it will go away in this location and then try to complete the circle with the positive value of tension. That means the tension will be there throughout this circle. At this location momentarily it will become 0 and then again it will assume the tension and then it will try to complete the circle because the velocity is still be there. So this is Ag, which is the magnitude of the velocity when the tension can become 0 at theta is equal to pi. So the velocity should be at least greater than 5 Ag so that to have a complete circle for the stone. Got it? Understood? Understood? Do you have any questions on this? Last two lines. See this. What happens is, we tried finding out the condition to have a complete circle for the stone. Now that condition should be, the particle actually should not be having zero tension at any point. That is the condition so that actually it can go a complete circle. Because actually if you tie up a stone with a thread, then it will try to rotate like this. Then actually it will try to rotate in a circular fashion because it will try to rotate because of the only reason that the string tension should be greater than 0. Suppose actually if I give a small revolution, it will come till this point and actually it will fall down. But actually if I give a bigger velocity, then actually it will try to hold my hand so that actually it will try to rotate in a complete circular fashion like this. Now here actually the fundamental condition is to have the complete circle, nowhere the tension should become 0. This is the condition. Now actually the only possibility where the tension can become 0 or the least possible tension can happen only at the highest point. Now that is at an angle of theta, which is equal to pi. So at the highest point where there is a possibility of having least tension, because the weight will drag downwards, at this location will be the highest height, right? So the weight will drag down at this location and that weight should be balanced by the centrifugal force of this particular particle. Now for that actually we have to be finding out at the topmost point the tension value so that we can assure that it is greater than 0 or at least greater than or equal to 0. Now for that actually we tried calculating the condition where tension is equal to m by a times of u square minus 2ag plus 3ag cos theta is the tension, and this should become more than 0 even at the angle at theta is equal to pi. So this condition actually it came to a conclusion that u square value should be greater than 5ag so that the tension can never be 0 at the topmost point. Now if it is equal to 5ag, then the tension can momentarily become 0 at this location. So even if it is equal to 5ag, u square value is equal to 5ag, the tension can become 0 momentarily. Why I am calling as momentarily is, when the tension becomes 0, it should fall down automatically, but it won't fall down because of the reason that even though the tension is becoming 0 at this location, the velocity still be a positive value, which we concluded from this relation where v is equal to u square minus 2ag plus 2ag cos theta at theta equal to pi. The velocity value is going to be u square minus 2ag, which is equal to v square. Sorry, this is v square, which is equal to v square, and this v square value u square minus 4ag, and u square value for the tension condition we proved that this is going to be a 5ag. So if this is 5ag at least, then 5ag minus 4ag is plus ag, which is definitely a greater than 0 value. That means though the tension is becoming 0 momentarily at theta equal to pi, the velocity is still be a positive value, hence momentarily it will become slack meaning no tension. So momentarily it will become slack, this line, that is the thread will become slack, but still the velocity is there in a tangential direction like this. It will try to drag, and because of the centrifugal force again, it will try to continue with the positive tension. So from this location, the particle will be having a positive tension till this point, and momentarily it will become slack, and then actually it will continue with the positive tension again. That is happening only if u square is equal to 5ag. If u square is greater than 5ag, then nowhere the tension is becoming 0, hence the circle will be definitely a complete. Got it? Understood? Yeah, great. So you can note down this. So this is about the constrained motion, and the same constrained motion, right? Okay, so note it down. Done? Noted? Okay. So now actually, so this is the case actually where we tied up with a thread and then actually we tried analyzing this particle. Suppose what happens in a hollow sphere if a particle is trying to rotate because of the force given at an initial velocity of u, then the role of tension is getting taken by the normal reaction on the particle. That means, so the analysis won't be changed. See this, suppose this is the sphere and this is the sphere. Let us say the particle is at this location, and for this particle actually I had given an initial velocity of u. Now this is a hollow sphere, so this particle is not tied up with any thread, but still actually we have given an initial velocity. It will try to go in a tangential fashion like this. Because of the constraint of the sphere, it will try to rotate in a circular fashion like this. Now this particle to have a complete revolution, then the same conditions of what we have calculated now is still be applicable, but only thing is, rather than the tension on this particular surface, the normal reaction will be in this direction. So this is the normal reaction direction, which is always towards the center. So this is the normal reaction. So the T value has to be replaced with R, and rest of the analysis is same, though the particle is not tied to any of the thread. So the normal reaction will take care of the tension role. Got it? So R value you can find out m by a times of u square minus 2az plus 3az cos theta, and v square value is u square minus 2az plus 2az cos theta. So these are the relations where the particle is constrained to move in a hollow sphere. Got it? Earlier one is a thread. So tension and normal reaction are one and the same. That's all. Got it? So this is how you can analyze in case of hollow spheres. So based on this understanding, we will solve one or two problems. So can you note down one? A heavy particle of weight W attached to a fixed point by a light inextensible string. By a light inextensible string describes a circle in a vertical plane. Describes a circle in a vertical plane. The tension in the string has the values. The tension in the string has the values MW and NW respectively. When the particle is at the highest and the lowest point. in the path. Show that m plus n is equal to m plus 6. Can you try to solve this? Okay, so let me solve it. So the tension relation is m by a times of u square minus 2ag plus 3ag cos theta. So this is the tension relation. Now here he has given the weight. So weight is equal to mg, or m can be written as w by g. So because actually we need the m value rather than the w. And then this is moving in a vertical circle like this. Now this is being the lowest point and this is being the highest point. At the lowest point, theta equal to 0 and the weight, so and the tension value he has given as n times of w. So in a vertical plane, as the values of mw and nw respectively when the particle is at the highest, so highest is mw. And this is nw where theta equal to pi. So this is the condition what he has given. Now if you replace it here, so at the highest point, so this is going to be mw is equal to m by a times, so m is, so this m is different, that m is different. So I hope you noted down. So this is capital M. So this is capital M. So this m is small m. So this capital M w by g into u square minus 2ag plus cos pi. So this w will cancel out. M is equal to 1 by ag times u square minus 5ag. And then if you take at the lowest point, so this is nw is equal to w by ag into u square minus 2ag plus 2ag cos 0. So 3ag cos 0. So this cos 0 is being 1. So this is going to be, so w will cancel and n is equal to 1 by ag times of u square plus ag. Now if you take the relation, that is m minus n or n minus m, if I take it, then actually, so u square by ag plus ag by ag minus u square by ag plus 5ag by ag. So ag will cancel, this will cancel, and then actually ag will cancel. So this is n minus m is equal to 6. It implies n is equal to m plus 6, which is the required relation what we are looking for. Got it? Understood? Any questions on this? Any questions on this? So like this actually, so we can solve other problems, but only thing is the constrained motion, which is in a circular fashion, we have analyzed without having any doubt, I believe. I didn't get your question. Any questions? Okay, fine. So in the next class actually, so maybe actually I will try to take the class tomorrow itself, because actually I have some work on Saturday. So in the next class tomorrow, I am going to deal with few more problems and then we will conclude this constraint motion. Got it? Yeah. So that's all for today. Yeah, thank you. Good night.